So we are recording, and I will wait for my clock to turn 12:01, and then we will start. I see 12:01, so let's go ahead and get started. Hi, everyone. Welcome to today's cryoEM Current Practices webinar. You're joining the 3 national centers established by the NIH Common Fund Transformative High Resolution Cryo-Electron Microscopy Program. So that's the National Center for cryoEM Access and Training, NCCAT, the Pacific Northwest cryoEM Center, PNCC, and the Stanford SLAC cryoEM Center, S2C2. My name is Christina Zamani, and I'm a member of the team at NCCAT, where I focus my efforts on our cross-training programs. And today, I'm your moderator for this webinar. This is the 4th talk in an ongoing series that takes place the last Thursday of every month at the same time. For those of you who have joined us before, welcome back. And you'll notice we have a new official webinar name, cryoEM Current Practices. So we thought this name captures our intention that this series features speakers who will highlight the methods they're using to understand and interpret the data that they can collect on the high-end instrumentation available at the national centers. And we hope these sessions make cryoEM methods more accessible for those of you who are newer to the technique. And for that reason, we aim to leave plenty of time for Q&A at the end of the talk so we can dive into the details that are most useful to you. For those of you joining us for the first time today, we're very glad to have so many of you here. We have 200 people in the room already. That's really exciting. If you want to see any of our past talks or miss one of interest in the future, we are recording, and we post our recordings on YouTube. So if you go to tinyurl.com/cryoEM talks, that will get you to our YouTube page. I also wanted to announce that we have a new web presence at cryoemcenters.org. So this is a brand new website we just launched that has key information about all of the transformative high resolution cryo-electron microscopy program centers. And that includes our 3 centers, as well as the newly established cryo-electron tomography centers and the 4 curriculum development centers that are building really exceptional educational materials to train the next generation of electron microscopists. So we hope this site helps the broader biomedical research community find and utilize all of these resources, because the mission behind all of these groups is to help you use cryoEM to drive your research projects. So along with that information and registration for future talks in this seminar series will be up on that website on the events page. And in addition to that, we'll continue to advertise upcoming talks on the 3DEM and CCPEM mailing lists on Twitter and email blasts from our centers. So look out for future talks. Back to today's agenda, we have representatives from each of the centers here who will give a quick introduction and let us know of any exciting updates from their centers. So with us here today are Rosemary Haynes, scientific point of contact at PNCC, Michael Schmidt, one of the principal investigators at S2C2, and Ed Eng, the manager at NCCAT. After they give their updates, Ed is going to give a proper introduction to today's speaker, Professor Mike Cianfrocco, who's joining us today from the University of Michigan. And we're particularly excited Mike is here today because he shares a similar desire to make cryoEM a more accessible structural biology technique. Also here on our panel today is Lauren Hales-Beck, the project coordinator at PNCC, and she'll be helping me manage the Q&A. Which leads us to some final logistics for the Q&A. You aren't able to turn on your microphones, so we will be using the Q&A window to gather questions. So please use that Q&A button at the bottom of your screen, not the chat button. We won't find your questions if they're in the chat. Feel free to send questions in at any point. If your questions are directed to logistics at the centers, our panelists will answer them in that Q&A box directly if possible. If it's something more complicated, we'll come back to it at the end. And we're going to save questions for Mike until after his talk. In that Q&A box, you can see that you can upvote questions. So if you go to ask something and the question's already there, give it a thumbs up, or if something's popular, give it a thumbs up. That will help us prioritize our discussion at the end of the talk. So that's enough from me. I will turn it over to the center representatives. Rosemarie, I'm going to let you go first.
Hi, my name is Rosemary Haynes, and I'm a scientific point of contact at the Pacific Northwest cryoEM Center. At PNCC, we have two proposal types, and those are limited access for preliminary data sets up to 24 hours and general access for larger projects up to 480 hours per year for 2 years. As for instrumentation, PNCC has one Arctica with K3 and 4 Cryos. 2 of our Cryos are equipped with Falcon 3 and K3, and the other 2 are equipped with Falcon 3 and BioQuantum K3. We'll be outfitting 1 Cryos with Falcon 4, Cold Fag, and BioContinuum. All of our Cryos will be updated with Fringe Free coming at the end of 2021. And for sample preparation, we have a VitraBot and Leica GP2 with a VitraJet coming in early 2021. At PNCC, applications are due every month on the 1st at 11:59 p.m. Pacific time. We leverage the EMSL user portal for all of our applications and proposal tracking. In general, it takes about 40 days for proposals to be reviewed and receive an award letter. Once approved, there's a recommended user onboarding with our user coordinator. PNCC offers both screening and data collection of single particle analyses and tomography on approved proposals. Additionally, each approved proposal will be delegated a SPOC or scientific point of contact, whom they can ask scientific questions and discuss their project specifics. PNCC is currently under restrictions and is offering one-on-one remote training and small remote workshops. Once we are able to host visitors on site again, we plan to offer small on-site workshops covering microscope operation and sample preparation. So apply today.
Thank you, Rosemary. Now I'm going to turn over to Mike Schmidt.
Good morning, good afternoon, good evening, and good night. I'm Mike Schmidt, and I'm one of the co-directors of the S2C2 Stanford SLAC cryoEM Center. We have available 3 Cryos microscopes and access on another one, plus a Talus. And we have as the Pacific Northwest one does, and of course NCCAT, different types of access for high resolution data collection, including a newly instituted one called exploratory access, which is designed for quick access to interesting projects. We have a special COVID one for COVID related research. So these kinds of access are available. We also have workshops. I'd like to call your attention to the one that we will have in early March, discussing that one will concentrate on data collection, and we will have representatives of all 3 of the camera manufacturers, Thermo Fisher, Gatan, and Direct Electron, who will discuss the updates to software and hardware of these new machines and the opportunities they have for high-speed data transfer. We'll have people talking about how to get all this data over to your computers. So check out our website and the workshops that are on the website, S2C2 workshops. That will Google you to us, and we hope to see you at these workshops and have you here for data collection. Thank you.
Thank you, Mike. I'm going to turn over next to Ed Eng.
Okay, hello, my name is Ed. I'm from NCCAT. We're here based in New York, as you can see in the picture here. We offer nationwide access to instrumentation, including 4 Titan Cryoses, as well as a couple of cross-training microscopes. Our main forte right now is cross-training. As we've moved to more remote operations, we have a more mature distance learning program. Right now, I would like to point out we have a graduate level cryoEM course being offered. Even if you missed the first couple lectures, everything's online, everything's recorded. We offer it in a reverse classroom style. And if you're interested, go to nccat.nyspc.org. One final note, if you're going to go to the Biophysics Society coming up next month, all 3 centers will have a joint booth, and you can find out more about our access categories. So I'm going to segue straight into introducing our speaker today, Michael Cianfrocco. He's coming from the University of Michigan Life Science Institute, as well as the Department of Biological Chemistry. Mike has a pretty good pulse on the nation's infrastructure needs, and this is quite appropriate because the National Center Program is truly trying to outreach and make sure cryoEM as a technology is well used. And so Mike has a good idea of the instrumentation needs out in the nation, as well as the computational demands. And the reason why is he grew up in New York, not too far from our neck of the woods. He did his doctoral work in Evan Nogales' lab at Berkeley. He did a small stint down in San Diego, where he actually does run a research lab. He fell in love with motor proteins and intercellular transport. But the main topic today would really be his tool development for cryoEM. And something that is really useful is trying to build cloud resources. He may utilize Amazon Web Services as well as the San Diego Supercomputing Center, really to allow users to focus on the biology instead of worrying about command line or Linux. But if you're interested in that, he's now trying to offer additional services related to that. So without further ado, I would like to introduce Mike again, where he'll be talking today about his cryoEM tools for access and to facilitate adoption of cryoEM across the nation. So I'll turn it to you, Mike.
Thanks, Ed, and thanks to all the centers and everyone for allowing me to be here today. So let me share my screen. Okay, all right, so hi everyone. Nice to see you all virtually. So I'm here today to talk about cloud computing tools in cryoEM, and you'll see I'll kind of survey a few different areas. If there's anything you want to talk about further, please reach out via email, or we can talk about it over at Twitter as well. So let's get started. So I think as many of us can appreciate today, where cryoEM is, that's obviously extremely powerful technology to solve structures of macromolecular complexes. But I think we also can appreciate that we have very nice instrumentations and very nice structures, but in between, it's definitely slightly harrowing as far as how you're going to be able to take all this raw data, crunch it down into structures. So I think what we're dealing with now is that your data processing is happening at different sites in data collection, your data is living in different locations, and you're sort of left to your own devices to figure out what's happening. Clearly, we can push through this, but there must be better ways forward. And so I think part of what we've now seen is that investments in national cryoEM centers, such as the NIH-funded initiative in the US and other versions in other countries, really has helped expand the access and impact of cryoEM. But I think what is interesting that's still missing is that you're sort of left to your own as far as how you're going to process your data. But when it comes to, I think the same logic can apply that it would be nice to have more centralized data processing platforms, just for the sake of spreading impact, reducing barriers. And so I would just take the second to sort of pitch that I think we as a field could benefit from more centralized computational platforms for the sake of, it would benefit structural biologists. It would also benefit software developers. If it was easier for you to deliver software, tools, algorithms without headaches, that would help everyone. I think there's going to be, by doing this, it'll be easier to determine structures. And I think that this will probably go both ways as far as both advancing science and research. I think it would be equally as well suited for education as for training all these new users. So I feel like this is an area that I think we should be, as a field, figuring out the best way for this. And today I'll tell you about things that I've done in this vein, but it's definitely not to the extent that would be, I think, the most helpful. So I think if you're here and you're doing cryoEM, you probably have some appreciation of the fact that you need some level of computing or high performance computing to do your work. And so if you make this plot that I like to use, if you look at the cost to set up your own cluster or machine, there is an upfront cost. And then once you have it, let's say there's low queuing time if it's just you or a small group of people. On this axis, there are other computers. Sometimes there are university supercomputers or university centers that have free or reduced cost, or there's even government supercomputers that we'll be talking about later that it's free, but you just have to apply for time and you have to sort of administratively be ahead of yourself. And so in the middle here is this area that we'll be talking about, which is called cloud computing. And let's just define cloud computing as just sort of any computing that's happening outside of sort of your physical building or your physical space. And so we'll be talking about sort of the public cloud computing platforms like Amazon and Google, but we're also going to be talking about sort of government supercomputers, and you could think of them as also cloud computing because they're, again, remote from where you are. So in the middle here is cloud computing because the upfront cost is low. Perhaps over time that number can change, but upfront cost is low and there's low queuing time because you can log on and get access immediately. And so I think we all sort of are familiar with the cloud at this point, where we as end users look at the cloud for website hosting, for some cloud computing, and also data storage like Google Drive. In the back end, there are a lot of companies. These are three of the largest companies: Amazon Web Services, Google Cloud, and Microsoft Azure are the back-end servers that let you actually do these different web tasks. And so if you break it down a little further, when you're watching Netflix, you're over here like streaming content straight from Amazon Web Services. You don't see any of the underworkings. Below this, there's sort of a middle layer that lets you sort of program what's happening. And at the very bottom, what you have are the actual machines that are doing, let's say, the streaming or the data hosting. And so today we're going to be talking about Amazon Web Services, where when you come in, you can plug straight into a machine and get all the access you need. And then we're also going to talk about at the end this science gateway that I've built that I call Cosmic 2. And think of that as more of the application cloud, where I've abstracted away all of the command lines, and now you're just looking at sort of websites. So the key ideas of cloud computing are that there's no upfront cost. You pay as you go to the minute, typically. And the nice thing here is that you can sort of plug in and start going, and you can start testing things, which is nice. The data storage is extremely reliable. I think we all have to deal with the data in cryoEM, and there's lots of ways to go, but here's where you could do sort of long-term storage or short-term storage, and it's very reliable. And the nice bit about the cloud is that it's very flexible, and you can choose whatever sort of type of computer you want to do your tasks, such as GPUs or CPUs, and that you can sort of get this for 1, 10, 100 of these very easily. Another feature of the cloud, this is an example of where all the data centers are for Amazon Web Services, that they're all over the world. And so that if you were to put software or tools or data somewhere, you can easily sort of replicate it, access it in other parts of the world. And so you can imagine developing software tools and hosting them in multiple locations could have an impact that's much easier to have than sort of one-off solutions over and over again. So to give you sort of a sense of what's happening on the cloud, I'm talking a lot about AWS. This applies to all the cloud providers, but this is just to give you a sense of things that are available, but also sort of a little bit of the cost that happens. So I'll be mentioning things called instances, and these are virtual machines on Amazon, and you can sort of plot this on, let's say, how much memory the machine has versus how many CPUs or GPUs there are. On the top left here, you can have very tiny little machines that have, tiny bit of RAM, a little bit of CPUs for really small tasks. On the other side, they have much beefier machines that can have, up to 128 CPUs, and then up to 2 gigabytes of RAM. And then, as you can imagine, there's sort of every flavor that's in between. You can have more CPUs, more RAM. They have a number of instances that have GPUs that are mostly used for deep learning, but we can also use them for cryoEM. So all these little names are what Amazon calls them. But the point here is that there's all these different flavors. You sort of pick, if you, as the end user, know what you want, it probably exists. Because it looks like they have up to 300 different types of these machines, because it's easy to sort of create any combination. So that's the machines. The numbers I think that we care more about are sort of what are the prices per hour. And so I say per hour here, but it's really to the minute, and it might even be to the second now. But this is an easier number to imagine, at least per hour. So you can see that these tiny machines are less than a penny, a US penny per hour. And some of the really expensive ones are up to $13 an hour, $14 an hour. And so that's sort of part of this, that there is this upfront cost, or there is a cost to doing this. The upfront cost is low, but over time, obviously they're a business, they're gonna make money on the fact that if you just keep using this, there is some sort of markup for them by giving this to you on demand. So to give you a sense of this, I thought I would just sort of do a calculation. So I feel like a very standard unit in cryoEM is a GPU workstation. These workstations have, let's say, 4 GPUs, some modest number of CPUs, and some RAM for the CPUs. And let's say this is about $18,000 in US dollars, maybe $20,000. If we looked at a machine that was comparable on Amazon, that's the name here. It has 4 GPUs. They're different, but they're similar. Comparable number of CPUs, maybe less RAM. Okay, so what are the prices here? So let's imagine your workstation is sort of warranty for 3 years. You take the 3 years and divide it into $18,000. It's about 68 cents per hour to run that machine. This is not including the power. So that's also, that'll probably double the cost probably. But this is what you see probably as a scientist. For Amazon, if you take the rate, the sticker price is $3.90 per hour, which is clearly an increase over what it might be in this example. But to give you a sense of how it can change is that you can sort of pre-reserve this. Let's say you knew you were going to buy it for 3 years, they give you a reduced rate. So this is to show you that it's more expensive. So the first point, it's more expensive to use Amazon, but you didn't have to spend $18,000 to do this. So obviously, if you use this machine nonstop for 3 years, you probably should buy this machine. But sort of the calculus here is sort of balancing sort of how often you're going to use the machine versus how expensive it is to buy it. And so I think that's something it's definitely individual specific, but I think it's an important point to keep in mind. So what can you do with this? So I think the thing that I ended up exploring first was building what I called a sort of hybrid cloud architecture or infrastructure, meaning let's pair your laptop or your local machine with Amazon through some interface. And so the first way I did this was I built this into the back end of Relion. And so this is what the Relion GUI looks like. I sort of took this and tried to submit jobs instead of on your local machine, run them on Amazon and bring the data back. And so the gist of what it was is that you were on your laptop and you could open Relion, hit run. The software I wrote that we call the cryoEM Cloud Tools would move your data up to Amazon as fast as it could. It would then move it down to a machine, it would run, and then it would be syncing the data back in real time. And so you as the end user actually wouldn't notice that it was running on Amazon because it just looks like it's running on your machine. And so with this, the way we did this, it was easy to do in Relion because of if people have used this, there's this queuing submission in Relion. And so you could go to the queue and instead of calling sort of some cluster command, we could change this and make it call our own command. And then now it's running our software. And with this, we could go in and sort of run through let's say now 1 point below 2 angstrom beta galactosidase data set that had been used previously for relying on GPU acceleration and show that this all worked totally fine. And we were, it was a little bit faster on the cloud. This was neat. So I think this was neat for us because it showed that there's this other way to process your data, which is you might have a local sort of limit to how much computing you have, but now you can sort of push jobs up to the cloud. And depending on where you are and what you're doing, that could be very helpful. For us, it ended up being helpful because we could submit many, many jobs at once and get science done faster than if we had to wait sequentially. What are other examples? So roll back a few years when Warp had just come out, and it was a preprint, and we all were wondering how would it do with our data set. And so for anyone who uses it, Warp is a great machine, a great software for pre-processing cryoEM data. The trick with Warp is that it runs on Windows. And so typically it might be hard to find a Windows machine that has GPUs on it that are amenable for Warp. And so what we did was we actually, because I had been familiar with Amazon, we could go to Amazon, we could turn on a Windows machine, install Warp, and then we used a data moving service that we already had installed on our servers at Michigan, at University of Michigan, and we could use it to move data from our microscopes up to Amazon, run Warp, and bring it back to our machines. And so it was really nice for us because it let us test it. And obviously that we all know now, Warp is a great piece of software. At the time, it was more like up in the air, is this going to be really important? We used it and it was obviously a great software. And so we now have our own Warp machine in lab. But at the time, it made it really easy for us to go and test it, use it, and turn it off. And that these machines we were using cost, a few dollars an hour. And so it would maybe cost like $20 or $40 for us to do this for a couple of days and turn it off. So it was really flexible and really nice. I think another example that sort of goes a step further is that, so I showed you Relion, we sort of just baked in the back end of Relion. You could submit jobs just taking Relion, running it. With Warp, it was just running Warp. We had been using Rosetta, and we still use Rosetta for modeling our cryo-EM density. And so what we did is we collapsed a bunch of Rosetta commands into one script. So you as the end user provided more minimal information, such as, let's say, your map, your FASTA file, your initial PDB coordinates, let's say, and then it would do all the rest. And for people who haven't used Rosetta, Rosetta has a lot of these files that have to be edited and customized. That just takes some practice and getting used to. And by wrapping it into this software, we ran it on Amazon, which is nice. And then we also sort of had a value added bit of, well, now we helped put some expertise that we got from running Rosetta into this, so it's easier for you to use. So I think it showed that you could do sort of a value add by writing software around, let's say, complicated commands that would make it easier to run and get you the results back. And so the final sort of example I'll talk about with AWS is running workshops. And so at University of Michigan, we've run 2 workshops on Amazon Web Services where users could bring in their own data. And so the idea was we have every user gets their own machine on Amazon, and that machine had 4 GPUs and CPUs and also data storage. And users could upload their data ahead of time using this data moving service called Globus. And then once the data is up on Amazon, we would bring it down to everyone's machines individually. And then for the week, while these participants were with us at University of Michigan, we had a workshop where we brought in developers from CryoSpark, System, we had Relion, you name it, was there, Rosetta, Phoenix, and people would come in and could process their data, and then they could bring it all back. And so it was really nice, and it showed that there's sort of something, obviously running through tutorial data sets are really nice because it lets you see how it should go. But processing our data and then processing it alongside other scientists and also with sort of experts and developers was really helpful. And I think it's an example where the cloud is really nice because where else can you get 40 GPU machines just for 5 days? It's definitely on Amazon. We did this sort of further by, at the American Crystallographic Association 2019 meeting, we ran a cryo-EM processing workshop where we gave 70 participants a CryoSpark machine for a day. And so by using this, we could give them all a machine with the T20S data and maybe some other data for processing, and they could sort of get their feet wet with cryo-EM data. And we've also used the cloud at the Cold Spring Harbor cryo-EM course. So I think there's definitely a big push now for training people on how to look at data, interpret it, analyze it, change software packages, sort of go back and forth. And I think the cloud offers a really great tool for that. Okay, so back to the space. I think I was just talking to you about Amazon Web Services. This is a cloud computing company. They want to make money. They're a business. Money's hard to come by in science, in academic science. So the other side. So as I was in San Diego, I sort of have been moving into leveraging what's called Exceed in the United States, which is a part of the NSF that funds supercomputers. And so Exceed offers the same services, but it's free for academics, which I think is would appreciate. And so they offer data storage, cloud computing, and also website hosting. So now let me tell you about this part. So what we've built and what is operational right now is Cosmic Squared, or Cosmic 2, which is a platform for determining cryo-EM structures. And when I say platform, this is going to be both the website and also other tools and sort of resources that are available. So the gist of this was that the command line can be a stumbling block for a lot of structural biologists. And so and also access to computing is hard. And so can we sort of take command lines and submit jobs straight to supercomputers without having to have users see command lines? And so that was the goal. We are now funded on a grant to finish this and build this. And then for more information, I would direct everybody to this website here, cosmiccryoem.org, or reach out to us to talk more. So the mission, as I see it, is to facilitate cryo data processing to enable image analysis for users of all backgrounds and all resources. And this is why I'm really excited to speak on this platform here, because I think these sort of national center-based approaches of expanding cryo-EM access needs sort of the equivalent for computation, and that's what this platform can offer. And so what I'll talk about is this, what we call a science gateway, which is this website that lets you submit jobs to the Supercomputing Center. And so I'll talk about this first, sort of the job submission. And then I'm going to say that this umbrella, like this mission, obviously we've been building infrastructure around the computing, but we've realized that the umbrella is bigger than that, that we probably should be providing access to supercomputers for super users, let's say. And we should be offering our expertise in computing to make more of a consulting service where you could ask us questions, or we could troubleshoot with you in ways that are maybe different or more specific than you might find on the sort of online email forums together. So I'll first going to talk about the Science Gateway, and then I'll just mention these two programs at the end. But I think for us, our charge is to help people do cryo-EM, and where our expertise is in computing. So to go back to the plot I showed you of sort of queuing time versus cost, what I imagine Cosmic 2 is doing is that I told you that supercomputers can be free, but there might be this sort of administrative delay or sort of the know-how of getting into it and running it. And my thinking is that the Cosmic 2 gateway lets us move this circle over here so that we're going to reduce the queuing time, and it's still going to be free for academics. And so this is what we like, and I think we would pitch it as we're removing both the IT administration and also sort of the bureaucratic hurdles of submitting and applying for computing time. So this gateway is hosted and built and lives at the San Diego Supercomputing Center. This is a supercomputing center that's had multiple supercomputers that have lived there, called Gordon or Comet, if you've heard those names. There's a new one that just came online in the last few months, and it's called Expanse. And so this is a new supercomputer that has all the bells and whistles, but I think the key points here are that it has, up to almost 100,000 CPUs. It has a couple hundred GPUs, and it has also some special ones that have large memory. In the back end, they have petabytes of storage, which is that each petabyte is 1,000 terabytes, so it's 12,000 terabytes of storage. And so our gateway is built on top of this. And so I think as a community, we have now the system built where we have Cosmic 2, it's living on top of a supercomputer. And so what can we do with it? And so just to give you a sense of what's happening is that over here, we have the San Diego Supercomputing Center. That's where the Expanse supercomputer lives. It's where our whole system is hosted and works out of. And sort of the first stumbling block you would have is, well, if you're going to upload anything more than a 3D volume, you're going to need to move data differently. And so what we built from the beginning, we built this software into it called Globus. And if you've seen me mention it a few times, because if you haven't used it before, it's a really nice data moving service. I know the national centers, at least some of them or all of them, have Globus for getting data back out when you're finished. It's really nice. And so the idea of Globus is that it sits separate from the web. It's a part of the web interface. And so users will click upload, and Globus will grab their data, move it over, and put it on our storage at SDSC. It's also nice because Globus can take care of our user authentication, and so we also don't need to maintain any of that. It ends up being handled through them. And so this is sort of the high-level architecture of what's going on, but that's sort of the extent of it. Now let's sort of just look at it. So the idea here is you as the end user come in and you will see a landing page that looks like this. And so if you go to this URL, this is the landing page. And again, think of this as more the application side of the cloud, or sort of the Netflix side of cryo-EM, where you're sort of way above the machines. Right now, we have a certain number of tools that we've built and incorporated, but at this point, we can add any tool we want. So that's also I'm glad to be speaking here, is that I think we as a community have to decide, well, what tools are going to be the most impactful to be incorporated into this kind of platform. And so please, I have tools that I think we should add, but I'm also looking for feedback on what tools that could be. So we have software that can run on individual text files or 3D volumes. We also have Relion installed for running all of the sort of particle stack operations. We also have CryoDragon, and also sort of some basic things like conversion scripts. And to give you a flavor of what we can take and the kind of data that we can handle essentially all of the cryo-EM data that you have. You could have micrographs, or even movies that we could upload. We can take particle stacks. We can also take 3D volumes. We can take text files. So we sort of figured out the plumbing to go from you and your data or a microscope to the supercomputer. And now we just need to sort of help this work and make it happen. So when you upload data, you will, on the gateway, what you see is sort of this system. And so in this example, this is what we have: a tutorial data set that we have a stack of particles already made for the T20S proteasome. And you as the end user, when you have your sort of Globus endpoint incorporated and running here through this gateway, you will click a box and hit transfer, and the data will be uploaded and will be ingested into the gateway. And so here you see that we will show you star files, and those will be your data files. The biggest question is all with the cloud in general is sort of how fast is this going to be for uploading? And because we're at SDSC, SDSC is on sort of the fastest internet you can get in the country. And so the limitations are mostly going to be where your data is living and where does it have to go. If it has to go over Wi-Fi, obviously that's going to be slower. But on the SDSC side, it's extremely fast. It's as fast as you can get. So you can upload stacks here. We can take this and run tasks. So let's say you're going to run 2D classification in Relion. What we've done is we've tried to build tools and sort of show the users the sort of the basic simple parameters, and again, when appropriate, populate them with default values, but also try to hide expert parameters that might be overwhelming to new users. And so here, if you click advanced parameters, you would see the things that more expert users would want to change or be able to see what it's using. And so here we have all these different options. And so, but by default, we have all the default values that you would have normally. So you take that and you hit run, and it will take the job and it will submit it to SDSC. And so part of this is that we are inside of a cluster environment. And so you might have a queuing time of minutes to 10 minutes, 20 minutes, or an hour. And so there is sort of a queuing bit here that is sort of, it fluctuates depending on other jobs in the cluster. But when you submit your jobs, you'll sort of have a task overview where you can see what jobs you've submitted, and it gives you sort of, you can look at statuses and outputs and your label that you wrote and so on. And so it has all this available for you, and it's nice as far as using this. To give you a sense of what we've had, so we've been sort of open for business, I would say, since sort of this early spring, where we had some beta testing users come in, and then we're adding tools, and then we added some tools that I'll talk about in a second in August, September, and then we've had a steady number of jobs submitted. So we've had almost 1,000 jobs submitted through the gateway since September, and we've had now up to almost 200 users, which we're excited about. We're excited to have anything that people are going to want to use. And so I think that's part of what we're trying to do, is to add tools that people will use. And you'll see in a second that not all the tools we have are being used all the time. And so I think that's showing us sort of usage patterns that we want to incorporate and think about what's the best way to use this kind of platform. And as part of this, we've given away up to 7,000 GPU hours through this since September. And so what we've realized is that this is if you look at the breakdown of the jobs that have been submitted to the supercomputing center, 90% of them are for DeepEM Enhancer, which is a modification tool. That's really nice. And so it's a DeepEM Enhancer is a software package that runs on GPUs. It runs long enough on GPUs that it's slightly, will take up a machine's time by running it. It might take 5 minutes, 10 minutes, or 30 minutes to run. But it ends up being a sweet spot where I think this is a tool that is enough computing that people don't want to do it themselves or go through the hurdles, but that it actually gives you results that you want to use. Because if you look at this, there's 1,000 jobs and 200 users. That means there's users submitting multiple jobs, which is encouraging to us. That means there's sort of something here that they like to use. From our side, we're wondering what else we should be adding that could have this much impact, and why people aren't using Relion, for instance, because we have that. Why are they not using other software packages? What else could we be adding? So I told you all about this sort of web platform. This is this website that you can submit your jobs to. This is what we want people to use. But what we've thought about as we think about our role in the field, we think there should be another area, which is, let's call them super users, where, in this gateway, in the science gateway side here, we abstracted away a bunch of the software into a web interface. And maybe there are times when you want to have direct access to rely on, to, let's say, CryoDragon, you name it. Let's say you want to see the nuts and bolts and be able to run really expert options or do things that maybe are hard for us to do through our gateway. And so we've realized that there are people who would like to use the software, who are very comfortable with the command line, but actually struggle mostly with access to computing and access to software that's compiled or know how to run it correctly. And so because we're already this gateway and we already installed Rely On and we know how to run everything, we should just open up the sort of the belly of this system to users who know how to come in and use it. And so the idea would be you would come in, you would use our computing allocation, and you would have access to the command line, and we would give you sort of examples of how to run the software. And so you could just come in and start running your data. So we're piloting this, and we think we would like to see how this lands and how this would go. And I think if you are interested, please reach out to us. You can find out more on our website for how to contact us. I think this is an area that could be good for us to expand into, because it could be that users would rather use Rely this way, for instance. But we think this is one way to consider. And so when it comes to these supercomputing centers, what we have to do as sort of the administrators of this, we have to apply for computing time. And we can predict it, but the more use cases and things we built in, and we can sort of predict the slope of the increase of users and job submitting, that's where it would help us ask for more time. And so we can ask for millions of hours if we can justify it. And so if this takes off, we could provide a lot of it through this way. There's obviously an upper limit to this. It is a finite system, and so there could be upper bounds. But we think for now we need to sort of just see what's the best use of this. And sort of related to that, again, thinking about this as a big umbrella, that we are more of a computing infrastructure or platform. The same people who might be having problems running software might need just consulting help. And I think what I've experienced is that I get lots of emails asking about what's the best way. Should I be using Amazon? Should I be using this Cosmic 2 platform? Like, how do I set up a machine? I've answered lots of questions about how to run computing things. And I'm always happy to talk about it, but I realized that I should be more explicitly advertising this, because I think I want to make sure everybody knows that this is a service that we would be happy to provide as much as we can. Obviously, there are some things that are out of our control, but we can share information we have to you, and sort of it can explicitly help you in ways that might be hard to hash out on CCP-EM or 3D-EM, but email us. But this is, I think, an example. And both of these are available. They're sort of Google Forms for you to submit on the website over here. So that sort of wraps up everything that I was going to talk about today. So the way I see the cloud fitting in sort of the ecosystem that is evolving, that includes national centers, is that end users are going to be sending sample and getting data off of national center instruments. I think somewhere in this sort of triangle is that the users could connect their data to our platform on Cosmic 2. And that this is nice because, again, Cosmic 2, at least as it's built right now, this can take data from users and can run jobs. And we can add jobs, or we can add tools that would be the most useful for national center users. I think that's what we're trying to figure out. And so this would work really well. This is nice for academic scientists because the computing is free on Cosmic 2. I think in the background, and the way I view it is, in the background, you probably have Amazon and Google. And if you're an academic scientist, it's probably too expensive for you to run all of your lab on the cloud. But my pitch to you would be that Amazon is a great place to test software, especially as there's sort of different operating systems, different things out there. It'd be a great place to sort of be testing this. I think it's really good for education, specifically on hands-on processing of cryoEM data. And Amazon has specific mechanisms where you can apply for computing to be free. And so I think it's worth pointing out. I realized I didn't mention this. The education that I did with the Michigan workshops and the American Crystallographic Association, that computing was free from Amazon, because as long as you sort of explain to them what you're doing and how it benefits education, they will likely fund you to do this. It's worth pointing out, I've definitely been in the field enough to see that there are startups and some pharmaceutical companies that do use Amazon. And so I think there is always a place for Amazon for them likely. And then I think I put this sort of grayed out cloud over here for pipelines, because we've been thinking about, our scientific hat is that we're thinking a lot about how can we make pipelines for cryo-EM. And if you could make a pipeline that just worked the first time through, that wouldn't be that expensive. And you could probably run that on Amazon or Cosmic 2 also. But I feel like there's sort of examples of as things can become more deterministic in cryo-EM, if at all, it could be more feasible to go to a cloud computing platform like Amazon. Okay, so with that, I want to thank my lab. I didn't talk about any of the biology that we're interested in, which is microtubule motor protein biology. I will acknowledge the sort of a postdoc funded in my lab who's working on Cosmic 2 and also applying deep learning to cryo-EM, Eli Lee. And I want to also acknowledge the sort of 2 developers that are part of this project that are both at SDSC, Mona Wong and Kenneth Yoshimoto, who are the people who really understand how to write Java and web stuff that I can't really do. And I also want to acknowledge that Neil Voss is a part of this as far as helping us make tutorial videos. So with that, I would be happy to take any questions. Thanks.
Thank you very much, Mike. That was amazing and a lot of information, and there are tons of questions. So I've been pulling them as they come up and trying to pull them together. So I'm going to start, and things that start coming in now, I'm going to miss right away, but we'll get to those as well. So I'm going to start with a question that actually is for you as well as the centers. And there was a question, is cloud on the fly cost effective for the centers that are running 24/7, 365? You know, in terms of like uploading and processing, and if it is effective, it then has the advantage of making the data available to users directly during and after the session. So is this something that makes sense and is going on? So I'll turn that question to you as well as the representatives from the centers who are here. Anyone can chime in on that one.
Sure. I mean, I think, you know, as I said in the beginning, I think if you turn on these machines 24/7, it's more expensive than probably buying it yourself. And so it seems like if you are a national center, it probably makes more sense to buy machines. It all depends on the costs and where the money goes and how it goes. It seems like local is better, but I think it is a scalability bit. I think the cloud is also nice for scale because you could scale it out more. It might be a stumbling block to only have 1 machine running warp, and maybe you need 5 or something at a time. So I don't know. That's my answer.
If you want a center perspective, in terms of data collection, most of our hardware is on-prem. Where it really shines would be when we're doing cross-training. A lot of our cross-trainees don't have local computation. And I was with Mike at the ACA workshop back a couple of years ago, and seeing the power of that, he's helped us feed that forward. And actually all our trainees that are remote have used AWS tools to do computing, that's learning processing from CrowdSpark to Reliant, et cetera. So that's where it's useful. And then afterwards, the researcher has more information whether or not on-prem versus cloud is useful for them. And they can make that balance. It's not a zero-sum game. You can use both. And in this case, we use both.
Awesome, thanks. So there's a very popular question in the box. Is Cosmic 2 available for users outside the US?
Yeah, so right now it's available to everybody who wants to use it. There's definitely a cap. You know, there's sort of an upper limit here, but the answer is it's available. We have users submitting jobs right now from all over.
And similarly, is it accessible to scientists working outside of academia?
So Cosmic 2 does require a sort of a software license for industry. It's free for academics, and there's a licensing process for industry.
Yeah, and actually there was a specific question about CryoSpark and whether you need a sort of your own specific license to use CryoSpark.
So for CryoSpark, we don't have that in our gateway. And so that's not for Cosmic 2. If you go to Amazon, you need your own license from CryoSpark, which is either an academic one or an industry license.
Let's see. There's a question about cloud computing when you're using a graphical interface, like selecting particles, refining beads for doing tilt series alignment in tomography. So can you maybe touch on that?
Sure. That's a big part of this is sort of what is your, I guess all of us now with all of our Zoom and virtual meetings, but your internet is important. And so it'll be as good as your internet is. Amazon, once you're inside of Amazon, the internet is very fast. And so the latency is usually okay. It depends, obviously, on where you are. But for us, when we were running it, especially out of like our institute, which has good networking, or my house, which is, we have okay internet right now, at least, it's okay. So not a big deal.
And another sort of logistical software running question, can you continue refinements or classification jobs after they finish? Like how stop and restartable are things when you're running in Cosmic?
So right now it's definitely more of like a submit the job, run it, get the results. It's not like necessarily the same way in Reliant where you could just sort of just click the continue button and it continues immediately. And so I think and because Reliant's been used so much less than other tools, we haven't like focused enough on like the mechanics of continuing jobs and sort of that aspect. But we'd be happy to, if that's sort of a big aspect for people, we can focus on that as well.
And actually, we had a question about you showed that the Deep Enhancer was getting a lot of use. Was that a single group doing tons and tons of computation, or is that everyone's running at once? Do you have any sense of why that's so popular?
I don't track like who's in groups. I see like reports on who's using it, and like I see clusters of people sort of coming on and coming off. It seems like a word of mouth thing because you'd see like one email address from one institution and suddenly see more from that institution. So I think I would say it's sort of just people are finding it, using it, and testing it. I think as a tool, I think it's definitely interesting to see what it can do, what it can help you with. It's obviously a map modification tool, which requires like knowing that you're modifying your map, and you should be careful always that it's what you expect, what it's what it's doing to your data. But yeah, I think otherwise, I think it is a useful tool. So for instance, I use it like when I run DPM Enhancer, I go to Cosmic 2 to run it because I don't feel like setting it up myself. So I think that's an example of like, oh, that's a tool that actually is helpful.
All right, let's see. There's a question. Do you think, what do you think is the current upper limit for sort of users per month on Cosmic?
I don't know. I think that's what's to be seen. So I didn't really mention this. This cluster switch over to Expanse is happening right now. And so before we were running on a supercomputer called Comet, which isn't as big as it. Expanse is bigger and faster. And so I think we don't know. I will say, for me, the statistics I see, they have like thousands of users and they give away millions and millions of hours. And so I think, and because we're considered this sort of science gateway, we're considered a community user group on this resource, we can ask for more things and we get sort of like special abilities. So it sort of lets us come to the table and ask for more than you would get as an individual.
So there are a couple of questions that I think we can answer in one go about sort of getting your data up into the cloud. Because there's a lot of data and transfer speeds can be gating. So how long does it actually take to get your data up into the cloud?
So like, okay, so probably a bad example is at Michigan, we have really good internet. And so we get like 300 megabytes per second. It depends on, it really comes down to like, where is your data living relative to the fastest internet off of your campus? And so I would just also, for anyone out there who has like networking problems with cryoEM, we're funded, the IT group here at Michigan is funded to do networking upgrades and sort of firewall stuff, but checking that doesn't affect cryoEM data movements. So we actually are benchmarking cryoEM data movement patterns, so we can talk about that. That's helpful. So I don't know, the answer is like, it could be as good as 300 megabytes per second. It might be lower.
All right, since you said you wanted to know what people want, there's a couple questions about, are you putting in X? So is there a plan for integrating M?
So it would be great, but that requires, Windows. And so unless we use the sort of Linux, modified version that I've seen people talk about on Twitter, we can't do it. There's no, in Exceed right now, there's no Windows machines. And so we can't do Warp or M unless we somehow did the things that I think I've seen, like Takanori, I think, trying of running it in Linux, but I haven't seen the latest.
All right, there's a question, and I don't know if you answered this, if Cosmic 2 handles raw data in movies.
So it can. We haven't pushed it very hard yet because people haven't seemed to use it, but we could easily add motion correction to it as far as like running rely on motion correction or motion core 2. We have storage in the back end. We also, again, there's a lot of finite things that we're not talking about. If everybody upload their movies, it would be a problem for us. But we can have that if that's sort of useful. And that's sort of the example of like the National Hunters and us talking, is to figure out, do we want to ship movies straight to us? Our thinking has been, you typically probably will mostly have micrographs because you probably hopefully did your motion correction close to when you collected data, but that might not be the case.
All right. There were also a couple of questions about the cost of sort of transfer and storage of data. So going back to your math about the cost of this.
Like, so Amazon costs, I guess.
Yeah, exactly.
Yeah, I mean, I think for people who are a little more savvy would know that Amazon it's free to upload data and they charge you to download it. There's sort of some rate to download it. And if you're academic, you probably have a reduced rate of downloading that. I guess like I haven't thought of it as a major problem because usually you're not trying to download all your movies again. Usually it's like a one-way street. If it is like a move my 5 terabytes up and move it all back down, there are costs that are associated with that. Typically though, you move your movies in, you align them and you do things, and you're only downloading like reduced data like micrographs or volumes or stacks. So there is a cost, but usually it's not as big as the computing cost.
Let's see, coming back to the box, so I'm a little less organized. Let's see. So someone asked about using rely on. So if you're doing it locally, you have this sort of like directory structure and everything is maintained, and you sort of lose that when you're running in Cosmic 2. So is there some way to get everything back in that logical directory structure?
So when the job runs, it will run in the same logical directory structure, but there is that, I think I saw the question go by of like the default pipeline.star that sort of like just that keeps track of it in the sort of history of your job history. We haven't updated that yet. We could think about, it would be easy to do, or just to like write something that would do that. So we haven't done that yet, but we could. But the data does get output into sort of like job number this and this and that. So it would keep some of the structures.
Awesome, thanks. I'm just gonna point out we're at about time for an hour. So Mike did say he can stay with us to finish up some of the questions. So we'll stick around for a little bit more and try to get a couple more of these questions. But for those of you who have another meeting to get to, thank you so much for joining us. Look out for announcements for next month's talk. And we are still recording. So if there's a question you see but you can't stick around, come back and find the recording and you'll see the answers to those questions. Right, so let's get right back to it. Let's see, someone asked if you're considering a similar type of service for data backup and sort of long-term storage. I think this is also something people are struggling with.
Yeah, I know. I think data storage is kind of a mess. Yeah, I know. I've heard proposals going in. I know like the SDSC, I think, was submitting a sort of a really fancy kind of tape-based system. Tape storage, which for anyone who doesn't know, is like a cheap long-term storage. I think it'll be around, and I think we could tap into that. I think there isn't anything clear yet for us. obviously you can move data to Amazon or Google for like long-term storage or like cold storage, but that it still can add up as far as costs go.
All right. There's a question about whether your AMI is publicly available.
Yeah, and so I think if you go to cryoemtools.cloud, you'll sort of get this information. Or if you just search cryoEM, I think in the AMI search for people who've done this on Amazon, you'll see it come up. But yeah, everything is freely available. It might be, I'm not maintaining all of them like to be bleeding edge as far as like versions and stuff. So there might be some updates required.
Awesome. And then someone asked, let's see, is your implementation available? Have you considered to contribute the functionality to Cipion?
Yeah, no, we've looked at Cipion a lot as far as like they are also, pioneering sort of the interoperability between software and cryoEM. I think for us, we haven't yet because we have this web interface. So Cipion has their own interface, and so I think there's been, for us, we've been trying to figure out. Obviously, it'd be nice to dovetail off of what they've done. So not yet, but I think Cipion people in the team are thinking similar, for sure.
And there's a question about response time for your consulting about computation. And this is new, so maybe you don't have an answer to that yet, but maybe an expectation on how long it'll take to, to get your valuable help.
I guess I felt like I wanted to make sure I advertise it for sort of equity's sake and make sure everybody knows that we are available for questions. I think it depends how many questions we get. We get like hundreds of questions and it'll be slower. So I don't know. Ideally within a week, I guess, within a few days to a week.
And there are a couple questions about data storage in terms of like how much you can store and for how long. And I'm not sure if these are directed particularly to the Cosmic use case or the general case.
Yeah, I mean, I guess for Cosmic 2, because we have sort of a finite amount of backend storage, we have sort of at some interval, we will remove all data. Right now it's every 3 weeks, but we can change that. It's mostly just making sure we don't fill up our hard drives full of people's data, but we could change that number if people have a use case or have a reason to.
And yeah, there's a question about like physically where the data is going and if there are issues getting the data there, if it's coming from like the other side of the world.
I mean, for Cosmic 2, we're using Globus for data moving, and so they will do the moving. And so if you have Globus on your end or wherever you are, like it will move the data and it will be as slow as the slow bottleneck for the internet.
Yeah, so the limitation is
it would move it in and it would live on our server.
So limitation is just your local.
Yeah, or if it's going across the oceans, by going under the oceans, it's a slow step usually. And
let's see, there was a question if you have any documentation for running cryoEM courses on AWS.
Yeah, nothing like really polished and official, but we've run 2 workshops at Michigan, this workshop at ACA. Someone else was actually asking me recently about this, so we probably should officially write it up so it's easier to like think of like best practices or considerations for running it would be probably good to have. But whoever asked that question, I'm happy to email me. I can talk more about it.
And there's a question about tomography processing tools and what your plans are for integrating any of those.
Yeah, I mean, clearly tomography is a big next phase for all of us. So and with national centers. So it's definitely on, my eyes are on it as far as the future. I think like for us, we're trying to make sure we get users in the door. And so if it's like, if there are things that if there's something unique that tomography users would really use that we could have, like we could totally do that. Just a matter of like letting us know or telling us why it should be in there or what it is. I guess I've hesitated with some tomography steps requires like, for like the bead tracking and things are really interactive. And so that's harder for us to do. But if it's like run some job or run some things, we can easily do that. So it's not hard for us to add new tools.
Yeah, and even broadening out what kinds of tools, there's a question about plans for cross-platforming with other structural biology techniques, X-ray, NMR. How lofty are your goals?
I don't know, it sort of becomes more a question of like kind of bandwidth and people on board helping us. And so if there are like expertise in those other areas, then sure. I guess I'm clearly like into this. I like helping people. I like helping science in the community. So I think if there's people who have ideas, like I'm all ears.
Yeah, and sort of in that same question was about implementing continued AI and machine learning advances, which I think are, I'm not an expert in the area, but I don't know what the difference is in computing resources for those developments.
Yeah, no, that's definitely what, like, there's a person in my lab who we've been working together in deep learning. And I feel like we're trying to add these tools. I think adding more tools into this platform would be nice. Or just like the tools to help you do further training. For instance, like training on, like we wrote a micrograph, like assessing program that we call MicAssess, and having that or having ways to have people upload data sets and further train neural networks, for instance, like we definitely have thought of that. I think AI is sort of definitely in cryo-EM with like particle picking and sort of continuous flexibilities. But I think there's probably more to be dug out of data and micrographs and things. And I think it's a good point that we should be considering how to, because that's where like all the computing in the cloud is usually driven towards, is like all the machine learning for, finding all the cats and dogs in your pictures and stuff.
Let's see. There's a question about the particular example is particle polishing with warp on AWS. And have you run into IO quotas or problems handling corrected movies?
I guess I did polishing and rely on the cloud. And you're right to point out that there is sort of like a very intense input-output sort of limit. For warp Reliant, it should be okay because you're just taking the warp data and doing a Reliant polishing step. For M, I don't know yet. I haven't run M myself yet. So it does require paying attention to it though. So it should be possible.
All right, I've got two more questions before we wrap up. So there's a question about sort of box sizes. When I think this is a related question when you're in the cloud, and this is probably very dependent on what resources you're using. So, if you're GPU memory limited, how do you think about what kind of box sizes you can use?
Right. So I guess I didn't emphasize this, and that's something that is also unique, and I probably should emphasize this, is that we all use like gaming GPU cards, which are sort of lower memory. So these GTX 2080s or whatever. The GPUs that we use at SDSC or on Amazon are enterprise grade GPUs, which have about double the memory. And so like the ones that we had before were K80s and P100s, which are pretty big. The new cluster, the Expanse supercomputer, has V100s, which are the next super fancy GPUs from NVIDIA. So I would say we're probably not as much limited in memory as users are locally.
Awesome. And then I'm going to grab the last question, which is not super specific, but sort of brain food that I thought I'd bring up is thoughts about having a workshop focused on helping users navigate switching between different programs. And I think, at least on our side, that's a question we get very, very often. So I'll pose that to you as well, because we're interested in hearing what you think about that.
Yeah, no, I think that would be good. I guess it'd be interesting to know what should the workshop really focus on, just like what the other software tools are offering versus the mechanics of like, how do I switch it or how do I like do this step. I agree. I think that's what we've wondered, if like some of not seeing as many rely-on jobs, for instance, or things. It's not that it's like people are still learning what each software can do. And so they don't know when they should be using it or if they should be using it. I think it's a good question and a good point. I think that is definitely part of it. Is the future. It is what we're all doing right now. We all switch between software like all the time. And I think showing people how to do that and when to do that is a good point. And I think we probably don't even switch as much as we should, honestly. We probably should be trying more software.
Awesome. Well, I think I hit all of the major points that came up in the Q&A. That was absolutely fantastic. We still have a lot of people here who are very interested, and you would be getting a very rousing round of applause
Right.
if we were in a auditorium together. So thank you very much for sharing that. I think all of this will help us get more cryo-EM practitioners out in the world and doing exciting science. So unless you have anything else, we're done, and we will see you all hopefully next month.
Yeah, great. Thank you. Thanks for the opportunity to be here.